Good day, everyone. I am Etheljean V. Nahiel presenting my paper entitled Comparing Water Extraction Indices to Extract Water Feature in Lake Mainit Using Landsat Images. The outline of this presentation includes introduction, which consists of background of the study, statement of the problem, objectives of the study, and significance of the study, then methodology, result and discussions, conclusions, and recommendations. Water is an important component of human lives, and without it, the survival of living things on this planet would be impossible. The sources of water may include lakes, rivers, sea, and stream. Water body extraction has become a very important part in remote sensing, since water monitoring plays an important role in water resource management. Also, water body extraction from remotely sensed images has become a research focus over 2 decades. Lake Mainit is the fourth largest lake in the Philippines. It has a surface area of 17,060 hectares, a shoreline of 62.1 km long, and a watershed area of 87,072 hectares. Lake Mainit is one of the known water bodies shared almost equally by two provinces, Agusan del Norte and Surigao del Norte. However, the surface area of Lake Mainit is changing through time. Thus, detecting and mapping its changes by using the most accurate water index is important. The main goal of this study is to map and compare water extraction indices to extract water feature in Lake Mainit. Specifically, the study aims to create a map of Landsat images of Lake Mainit using water indices, to identify the most accurate water index that would provide best result on a satellite data, and to detect and map the surface area changes over 20 years period 2000 to 2020 using the most accurate water index. This study is beneficial to the government, to the environment, to the residents near the lake, and to the future researchers. This study composed of three major components. The first one was the data collection and image pre-processing of Landsat images of Lake Mainit using water indices. The second one was the accuracy assessment, in which we will identify the most accurate water index. Then the third one was the change detection of Lake Mainit from 2000 to 2020. This figure showed the overview of the methodology. 5 Landsat images were downloaded from USGS Earth Explorer in GeoTIFF format. Then image pre-processing of the images, then the processing of the water indices applied in this study, then the validation point extraction via Google Earth per year, then validation point selection, then these images were classified through maximum likelihood classification. The water indices were compared through accuracy assessment. Then the most accurate water index will be used for the change detection and mapping of changes. Then the change area is statistics. 6 water indices were applied to extract water feature in Lake Mainit, including normalized difference water index, modified normalized difference water index, general water index, new water index, and automated water extraction index shadow and no shadow. These maps were the Landsat images of Lake Mainit in the year 2000 using water indices. In the year 2005, year 2010, year 2015, and the maps of Landsat images of Lake Mainit in the year 2020 using water indices. To validate the accuracy of the water indices applied in this study, 5 sets of validation ground control points representing each year were generated from Google Earth. 50 for water and 50 for non-water with a total of 100 points per year. To identify the most accurate water index, the water indices were compared thoroughly. This table showed the accuracy assessment of water indices in the year 2000, in the year 2005, in the year 2010, year 2015, and the accuracy assessment of water indices in the year 2020. Overall, modified normalized difference water index and new water index had the highest overall accuracy with 100% and kappa coefficient with 1, consistently per year. In detecting and mapping the surface area changes of Lake Mainit over 20 years period, modified normalized difference water index was used, since most of the studies proved that this water index was the most suitable and capable for extracting water feature. In addition, modified normalized difference water index would be very useful for more accurately extraction of water bodies from image data. These figures were the change detection maps of Lake Mainit between 2000 and 2005 and in between 2005 and 2010. These were the change detection maps of Lake Mainit between 2010 and 2015 and in between 2015 and 2020. These were the change detection maps of Lake Mainit between 2000 and 2010 and in between 2005 and 2015. The change detection maps of Lake Mainit between 2010 and 2020 and in between 2000 and 2015. Then the change detection maps of Lake Mainit between 2005 and 2020 and between 2000 and 2020. The estimated surface area of Lake Mainit in 2000 was 180.1 square kilometers. In 2005, 174.67 square kilometers. In 2010, 193.90 square kilometers. In 2015, 172.70 square kilometers. And in 2020, 170.25 square kilometers. The surface area changes of Lake Mainit from 2000 up to 2020 were showed in the second table. This study concludes that modified normalized difference water index was the most accurate and suitable water index for extracting water feature. Based on the results, the surface area of Lake Mainit from 2000 up to 2020 had decreased with negative 9.76 square kilometers. This study recommends to use modified normalized difference water index to extract water feature quickly and easily, and to apply different water enhancement methods and techniques in order to have best result. Thank you for your attention.